We are given a region, and the region is bounded by the equations y is equal to square root of x minus 1, y is equal to 0, x is equal to 5. For square root of x minus 1, it's this one. We just take square root of x and then shift to the right 1 unit. And for y is equal to 0, it's the x-axis. For x is equal to 5, it's this vertical line. So this right here, it's the region that we are talking about. And we are going to take this region, rotate about the x-axis. So we are going to do this way, and this is the solid that we are going to generate. Our goal is to think about how can we calculate the volume of this solid. And the strategy for this is that, as you can see, if we do the vertical slice, and we can use a CD to illustrate what's going on. So this is called a disk method. You can hold up CD, and you can place the CD vertically, and this is how you are going to do it. And let me just remind you real quick. The idea is that we are going to calculate the area of each CD and then add a bunch of them. But then it's not really area. We are going to calculate the area of the CD, but then each CD has a thickness. So technically, a CD has a volume. Let me remind you, how are we going to find the volume of a CD? As you can see, the area is a circle, so we have to have pi r squared. And then we also have to consider how thick the CD is. So let me just write this down as pi r squared times thickness. So this right here will consider one CD. And then the idea is that, just like the one I draw in red, we are going to calculate the volume of one CD when you have the thickness, and then add them up, add a bunch of them. So we are going to get the integral of all that. This right here, it's called a disk method. And remember, CD it means the compact disk. The compact disk. So the names suggest me to use a CD. Anyways, here's the integral. So let me just show you volume by the disk method. So this is just a reminder. I should box this right here. And we should use the disk method. And another reason for that is because you are given the equation y is equal to a function of x. And then if you have this situation, y is equal to a function of x, and then you're rotating about the x-axis, the disk method is the way to go. Okay? And there's no gap, so I'm not going to call this the washer method, so there's a difference. But anyways, as you can see, if you hold out a CD like this way, what you should be doing is think about how are you going to calculate the thickness. It's either dy or dx. Okay? Because I place the CD vertically, as you can see the one I'm drawing red, the thickness is going to be the small change in the x value, right? The small change in the x value, so it's going to be dx. So let me write this down, dx. Because if I know this is going to be a dx situation, I'm going to have my integral sign. Because this is dx, I can refer back to my 2D picture and look for the beginning x value and the ending x value. It starts at 1, ends at 5. That means x has to go from 1 to 5 right here. So this part will take care of the thickness part. And now, as you can see, the pi is just a constant. You might as well just take it to the outside of the integral. So let me do that right here. So I'll put a pi right here, okay? And I just have to figure out what's the radius going to be for us in this case. And the radius is just going to be from the x-axis to the top. This part, right? And this right here is exactly the y value. This right here is the y value, right? So if you just imagine, look at this right here. It's just the y value. Take this part and rotate it. That's the radius. And I'm going to square the radius. So let me open the parentheses, put the square down first. There's no subtraction going on because there's no gap in the middle. So I can open the parentheses, square that, and the radius is the y value. But then y is not invited in the x world. Okay, we're talking about dx. So y is equal to square root of x minus 1. We are going to enter square root of x minus 1 into the parentheses, and this right here will be the setup. So the volume of this is going to be pi times the integral from 1 to 5, parentheses, square root of x minus 1 squared dx. And then let me show you how we can run through this integral real quick. Square and the square root cancels, so we're just talking about this integral, pi integral 1 to 5 x minus 1 dx, and then we're just going to integrate this real quick. This will give me x squared over 2, and negative 1 will give me negative x. and then pi is still on the outside, and make sure you use parentheses accordingly. And now I have to plug in 5 into all the x, plug in 1 into all the x, and then subtract. If I plug in 5 into all these x, I get this part. If I plug in 1 into all the x, I get that part. I have to do this minus that. And then if you work out the fraction, this is 25 over 2 minus 5, you get 15 over 2. This is 1/2 minus 1, which you get negative 1/2. 15 over 2 minus negative 1/2, which is 16 over 2, and that's 8. And then at the end, don't forget to multiply by pi. Altogether, your answer is 8 pi. 8 pi would be the volume for this solid. That's it.